Simpson's paradox. So with this phenomenon, we see that a trend either disappears or could even reverse when groups are combined. Let's look at an example. Let's say we're looking at the number of hours studied, and we could say, let's say, high school, I don't know, high school grades. Let's say hours can go from 1 hour, 5 hour, 10 hours. And let's say high school grades, let's just do 100, 90, maybe 80. So let's plot some data. So these are all students. Now, what happens if we try to run a regression on this? What ends up happening is we get a regression line like this. So this is the overall population, and it fits quite well. Notice there's a downtrend. Hey, wait a minute, that doesn't make much sense. The more hours you study shouldn't lead to lower grades. So overall, let's see, grades drop with more studying. So what's going on with this mystery? So let's actually color in what grade these folks are in. So here in blue, let's say these folks are in 9th grade. Let's say the red folks are in 10th grade. Green folks, let's just say 11th grade. And let's have orange be 12th graders. Now, what happens if you actually try to draw the relationship within each grade? So with 9th graders, our trend line looks like this. 10th graders, it'll look like that. 11th, 12th. So notice, this makes much more sense. The more hours you studied, the higher grades. And that trend line is represented, is described within each grade. And I don't know, one potential reason might be, hey, as you go up the high school grades, it gets harder and harder, which is why you see these downtrends. 12th grade is much harder than 9th grade. Maybe that's why the average is a bit lower. But it's quite important to look at the group level because the groups are inherently different. They have different levels of grades to begin with. Again, 9th grade being much easier than 12th grade. So the relationship should be represented and modeled within the grades versus the overall population.